So you guys could, I guess, is this like an audition if I do well enough? Cool. So, how was your weekend? Good weekend? Anyone actually do any React or Firebase over the weekend for funsies? This guy did. No? Yeah? Oh, very nice. Some of you might have noticed some random airdropping going on, those that have Macs or iPhones, just a little bit ago. It was
Sorry. I'm reviewing your video from last week. I just got to how to mute this.
Usually it's a student that does that in class, not the professor. That's right, yeah. No, so anyway, yeah, so today's class we're going to go over Firebase security rules, and in order to do that, I had to write up a little bit of Firebase auth code into our React app. So I sent out something over Slack that said that you guys should check out the pre-class 3 branch. If you haven't done that, shame on you, but that's all right, you got time. Before we hop into that, I've got a slide on here that shows exactly what you need to do, but let's just kind of go over some stuff here. So Firebase security rules, it's essentially structuring the unstructured. And just generally looking at everyone, I'd say that if I do choose to come back here, I won't make any slides because apparently slides doesn't capture attention like code examples do. So, I don't know. There are a couple of main things here, 4 main things that security rules do for your Firebase application. First of all, authorization. It allows people that are not authorized in your app to not access your data, keeps them out. Authentication, meaning that if certain people in your app shouldn't see certain parts of your app, then it will handle that for you. Validation as well. My biggest pet peeve using Firebase or any JSON-based data store is how easy it is to override certain things or to create nodes where you don't want them. There were like probably 2 or 3 of you guys that came up and talked to me right after class, last class, after we actually started pushing messages out, because you forgot to put a .child in your call. And if you went and looked at your Firebase, it created like a bunch of random stuff in your Firebase because you were just writing to the wrong node. And with validation rules, you can have Firebase reject stuff like that rather than just accepting it and messing your entire data store up.
The fact that none of those tools came to me for that question is a really good sign.
Yeah. Well, thank you. And then the other thing you can do is index your data for faster querying, which is really nice, especially when you start querying by child attributes.
Really? Security rules let you index the data?
Yep, absolutely.
That seems so strange to me.
Yeah. So the security rules really, it's not. It's in my opinion, it's a misnomer. It's not just security rules. It is. It would be better to call them configuration rules that just happen to deal with security as well. So the format is just an enormous JSON object with there are a couple of built-in functions and variables that you can use, and every attribute needs to evaluate to true or false. You can check current or incoming data, so like new data coming in or data that's currently in your Firebase for different values, and you, like I said, evaluate to true or false. Again, this is structuring the unstructured. All right, JSON can be very unstructured, and this is a way to provide some structure to it. Here is an example of what I've got right now, just a portion of our security rules for my capstone that we're working on. A couple things I want to point out here. $sign denotes a variable. Wow, this guy is dying. So a $sign denotes a variable. So you see here like $studio or anything like that. Anything that starts with a dot, like .read, .write, those are built-in, kind of attributes or nodes that Firebase gives. So that is a, what can you read, what can you write. Something else to notice here, index. You got .index on. We're indexing our lesson node on lesson time start, so that when we query, we can query by lesson time start and get our data back quicker. And we've got some validation rules in here, making sure that a lesson time start is a timestamp. It better be a number, and that the value is not equal to 0. And if any of those evaluate to false, you'll get, which is in my opinion wrong, you get a permission denied error in your console. So if I were to send data up to Firebase that didn't agree with any of these rules, rather than getting an error back in my console saying a validation error or permission denied error because I don't have the right permissions, anything that happens in here that goes wrong, you get a permission denied error, which can be super hard to debug because you're not sure if it's actually your permissions that are set up wrong or if it's your validation that's set up wrong. But regardless, just take that for what it's worth. So the whole concept of creating Firebase rules is very much like modeling in NoSQL. It's very iterative. It can result in changing your data model. I've found that as I will create a data model to begin, I'll then write my code to access that, and as I'm writing my code, I iterate over my data model to make it better so that the accessing from the code side is easier. And then I start to apply some security rules, and that makes me then reiterate over my data model because it might not necessarily be structured the right way for maximum security. And so, two big things here. Remember to validate as well as authorize. You authorize with auth. This you can see in here. This laser will actually show. Auth is not equal to null. You can access the UID on the auth object. You authenticate with .read.write, validate with .validate rules, and index with .index on. Cool. So that's just a brief intro to security rules, but let's go ahead and get into it and start writing some. Is that you, Gov?
That's my spare phone.
Okay.
My other phone.
So anyway.
I have your attention.
Yeah.
I'm trying to load the pre-class 3, and it tells me I've got to commit what I had before there wasn't overwritten or something.
Yeah.
I just don't know how to commit it.
Oh, okay. Yeah. So it's
You can just stash it. Get stash. What do I say?
You should just be able to say. Oh yeah. Let me go ahead and make this bigger for you. So if you want, you could get add all and then get commit, or you could get stash like that. Yep. So, preparation for today. You guys should have gone out and gotten some stuff, but just so you know, there are some things that I did in preparation for today. And I always like getting credit for my work, so I'm telling you exactly what it was I did. So I enabled email and password authentication via Firebase console. I'll go over these steps real quick so you guys can see roughly how to do this if you want to go out and do some auth, since we, as of right now, don't have time to go into authentication. I added several users manually via the Firebase console, and you guys are going to be using those users. I changed up the React code a bit so that now our login page, instead of just saying what's your name, it actually asks for an email and password, and you have to authenticate via Firebase. I updated our data.json file, and finally I updated I used that updated data.json file to update my Firebase DB. Also, I specifically left in my API config so that you guys, when you pull it, you should be hitting my Firebase. So like today's, instead of going and actually accessing your own Firebase, like you should be accessing my Firebase. We're all going to be interacting in the same Firebase today. Things you did or should have done is pulled the pre-class 3 branch from the repo. And all you need to do is run git pull just to make sure that you have a reference to that branch, and then check out pre-class 3. Is anyone having any issues in doing this step? Cool. All right, so let's go ahead and get into it then.
Okay, so when I run that last step, it says switch to a new branch. And then it says branch pre-class 3 set up to track remote branch pre-class 3 from origin. That's what it's supposed to say.
Yes, that's what it should say. So I made a new branch called class 3 off of pre-class 3. Just if we change anything, that'll be on its own separate branch just for you guys. Before we go into anything, I want to point out a couple of really great resources. When it comes to learning Firebase security rules, what I teach you guys today will be beneficial, hopefully. However, this video right here, it's like 50 minutes long. this truly was, to me, one of the best ways to learn Firebase security rules. So if after today you do want to dive a little bit deeper into it, come watch this video. All you have to do is just Google, I think it's like Firebase security rules. And the very first hit right here will take you to this page. And here's this video. And once it loads up. The video is great. It was from a Google I/O session a couple years back. Watching this video and then actually writing Firebase security rules will be the best way to learn. So I would recommend doing that. Also, I think it's at the very bottom. Yeah, so there are a couple of things that you can kind of go over here, but at the bottom here you can go to these securing your data or specifying indexes. And this secure your data page is very, very good for some great code examples and different ways to use built-in variables and things like that in your security rules. So I just wanted to toss that out there. So feel free to follow along in your own Firebases if you want to, but like I said, we're all going to be hitting the Firebase today, the one that I've got up. So just to go over real quick what I did to set up the authentication and everything, just as a kind of brief overview of that. First thing you do is you click on authentication here on the left once you've opened up your Firebase, and you click over to sign in method. You don't add users first, even though that's listed first. You go over to sign in method, and you have to enable a type of sign in provider. So by default, all of these are disabled. You can enable OAuth sign in via Google, Facebook, Twitter, GitHub, and then you can also enable email password. So I've enabled email password. All you have to do is just click on it. You click the little switch for enable and save that, and you can go in and do that. There's plenty of other stuff you can dig into here, especially if you're going into a production app. But once that's done, you can go over here and add users by email and password. As you can see, I've added a bunch of users here. Greg Anderson at BitByBitTech, Tom.Maservi at Windows Server, GovAllen at Gmail, my email, Stephen.Little at CodingFrenzy.com, Rick Moranis at Spaceballs.com, and Bonnie Anderson at WomenInBusiness.com. So feel free to grab any email that you see listed here and use that as your user today. I'm sure that there are going to be plenty of users that are using the same ones, but write down real quick the email for one of these users, and that will be the user that you log in to the Colonial messaging service today. There's a question. So are you talking about Amazon's RDS? I don't have a huge amount of experience with RDS, and so I don't think that I'm qualified to answer that question. All I know is that I set up all of this, and it took me like 5 minutes. I don't know how fast RDS is or how quick it is to set it up, so I'm not sure how I can answer that. So, sorry. All right, does everyone have an email that they picked out?
Well, yeah, mine was easy. I chose mine. Did you use my real password too?
No. No, I did not. Actually, the password for all of these is a super secure password that I made up. It is testpassword1.
You said you weren't using my real password.
The T isn't capitalized in this one.
That's right, yeah. Yeah. So the other thing that I've done in here is if you open up your data.json file, I have added a new node called user. And in here, from what I can see in the small amount of experience that I have, it's fairly common to nest in your user. Well, actually, before I get into that, let me also highlight something that was fairly difficult for me to understand at the beginning. These users that you see here are maintained in what you can deem a separate database. These users are not automatically added to your database node. So if you go to database, you can see there's a user node, but that's because I manually added this. You can delete all these users and have no user node in here whatsoever, but this authentication database is maintained separately, which is kind of nice, but it also is super frustrating. So if I add a user here, that means that I have to make a second Firebase call to our user node to then record information and save information about that user. So it can be a little frustrating at times to do that, but I just want to make sure that's very clear. Your users maintained in this list right here, or users that sign up in your application, are not tied directly to users in your user node. You need to do that manually. So what I've done in the data.json file is added users by their UID.
The only reason you want to do that is if you want extra information about that user.
Yes, that's right. So, for example, when I created, I mentioned this before, I went and I created these users manually. You'll notice there is no name for these users. There's no, if you need a birthday or anything like that. All you get is email, and that's it. So that can be a little frustrating, and I'll show you a little bit about how to deal with that. But in here, you've got the UID that's generated by Firebase. When you create them, you get a user's UID over here. So you can copy that, and I've got them nested by here. So their name is associated with their email, and their UID is nested in here as well. Now, you might ask, why is it that the UID is the key, but you also have it right here? And that is just for convenience, specifically. You'll see when I show you the code as to how we actually get the user object, it makes it much easier to have that on the object itself, especially if you're pulling back multiple users for like an admin user page or anything like that. So very, very basic. We just have their name and their email in our user node, and this will allow us to go into here. So if you guys run npm start, you should be presented with a page that looks like the page we had before, only now you have email and password instead of just name. If we want to dive into the code and look at this, it is the logincard.js, and I made a couple of changes here. Specifically, I beefed out the handle submit function that we had. Yet again, this is not a class on Firebase Auth. If you guys have some extra time at the end of class and you bring me back, I'll talk more about how to do all of this. But the main thing that you want to look at here is Firebase.auth, sign in with email and password. You grab their email and password, and it returns a Fire user. Now that Fire user is not this user right here, right? That Fire user is an object that Firebase has. It's their object they store in their user's authentication database. So that has the user's email and it has their user's UID. And that's pretty much it. If you happen to be authenticating via OAuth, it also might have a picture, like their Google Plus picture or their Facebook picture, GitHub, whatever, and it might have their name from those applications as well. But for the most part, you can just pretty much guarantee it's got a UID and it's got an email. That's it. So I take that Fire user here, and I then make a second call to our users ref, and I grab the value from the users ref based on their UID here. So if I log in with my email address, this will return back in the second Firebase call this user object with name, email, and UID. And from there, I then set our user object and move forward. And if I've wired up just a couple of quick things that if I enter in an email that's not recognized, email address is badly formatted, or if it is an email address, it'll attempt to log in. There's no user corresponding this identifier. All these are actual codes returned back from Firebase. I didn't actually catch those. Those are things returned from Firebase, which made it very quick to get up and running. So I'm going to go ahead and sign in with my user. Again, all passwords are test password 1. All lowercase. And I see that people have already started messaging in here. Perfect. So, that is just a very, very brief whirlwind over Firebase Auth. When that happens, when you log in, Firebase actually installs a cookie on your browser, and you are considered logged in. Now, just for sake of development and making this easier, if you go to your main page.js, we talked about React lifecycle functions, and on component will unmount, because I didn't want to have to wire up a sign out, on any time that this component unmounts, which could be on page refresh, it could be if you navigate away or anything like that, we are signing the user out. That will remove the cookie, and that means that next time you come, you have to sign in. That's just because I didn't want to spend an extra hour wiring up logout and things. It is, yeah, gov.allen. And again, there are great users such as Stephen.Little at codingfrenzy.com or greg.anderson@bitbybittech.com.
So it looked like there was a username that was your worst nightmare. Is that a username that you put in here?
I did not. I did not put that in here. And
That was before.
yeah, I'm pretty sure that was before here. And I've also noticed
Oh, I see.
we've got the real gov in here as well.
You copy?
Yeah. So
Is that you? Oh, sure.
yeah. So anyway,
But my point is, so those are did someone make the real gov today, or was that messages from before?
so the way that I understand it, to be perfectly honest, unless someone is going in and editing their state or they are hard coding in stuff with their user, we are reading these messages that are being sent here based off of the user that's in state, name, email, UID, and that is just taken from whatever it is that they log in as. Now, I did not create the real gov today, and I did not create your worst nightmare, so someone might be hard coding that into their application right now. They log in as someone, and so it's registered with a Firebase user. But if I hard code this in as Derek the Playmaker Hasvold, and my email, if I hard code that value into here, then it should show up as that. So, anyway, we're now in. Are there any questions? Again, today is supposed to be about security rules, and so I don't want to spend too much on auth. But are there any questions that are quick about authentication or anything like that in Firebase or any of the React stuff? No? Cool. Okay, so I added a new file in here called rules.json. Go ahead and open that file. And in here, you can see it's just a blank JSON object with rules nested at the top. It's similar to what we have currently if you go to database and rules in Firebase. It's just rules, and you see what we have right now is read is true and write is true. So if I change these guys, like I said, each of these attributes, here we have the key, all right, and so the key is either a node name or an attribute name or anything, or a built-in Firebase, attribute, if you will, parameter, and then the value must evaluate to true or false. So if I put false in here for read and false in here for write, a quick command in Firebase rules is you can hit Command S or Control S to save it, and it automatically publishes your rules for you. So if I do that and then pop over to here and attempt to write a message, I get a warning here at the end saying permission denied. We get an error here as well, permission denied. And my assumption is, unless you guys have somehow hacked our application, you won't be able to write anything as well if you try and send any messages right now. But that also means that if I refresh this page and attempt to log in, our login process will be broken as well, because there is a cascade to these. If there is no node listed beneath it, that means that this applies to every node in our entire Firebase. And so we'll be able to technically authenticate because the authentication database is maintained separately from our users database, but our code will break because our code attempts to grab the user from the user's node.
Okay, so John, you said that perhaps it was hackable, but I don't see how it could be.
Yeah, so I don't see how it could be either. I'm just giving that, just in case I start to see messages show up here, I want to cover my bases. So, let's go in here and let's actually write some rules that will make this application a little more production ready. And to start, I want to introduce what's called the simulator. So if you click on the simulator on the right, you see this little flyout come out. And this allows you to run simulated queries against your data using rules that you write right here before you publish, which is really nice. So if we swing over here to our data, we can see that our data has a bunch of messages already, and we have some users. So why don't we go ahead and start writing some rules and use the simulator against what it is that we're writing. So first thing I'll go ahead and give you guys is that, like I said, the rules cascade and they overwrite previous rules. So to start, let's go ahead and say that to read the very top level node, a Firebase user must be authenticated. So to do that, you're going to say that auth is not equal to null. And not only that, I can't really think of a time when we want any user, other than admins that have access to the Firebase console, to be able to create new nodes on our top level node. So for example, in our data.json, we don't want a user to be able to just say, hey, you know what? Due to a code error or due to them trying to break our application or anything, I'm going to go ahead and just create a new node up here called whatever I want. We don't want that. And so let's go ahead and say that by default, writing at this top level node is false. No one can write to this top level node. So if we attempt to read at our message node, which this is what you do right here, you're going to simulate a read at whatever node you want. Let's try and run it without it being authenticated. Simulate read denied. The details is that our rule on line 3 was that you have to be authenticated to actually read anything. So you can flip on this little switch here and simulate as if you were authenticated. And we'll say that you're authenticated. We actually have not allowed anonymous authentication or Facebook, Google, or Twitter. So you just come down to custom. And here you see that this is what's going to be sent up. So we'll say provider is password. And then this is just some randomly generated UID right here that Firebase generates for this simulation. Right? So now if we attempt to read on the messages node, that simulated read was allowed.
Okay, so why did you...
Password, that is just because I'm familiar with Firebase, and when you pull down a Firebase user that you've created with an email and password, that's the actual provider that they send it. Yeah.
So it's not email or Facebook.
Right. And if you signed up via OAuth, then it would be like google.com or facebook.com or twitter.com or anything like that. But since these are people created with that, it's just via password. Any questions? It's all making sense? So, what if we wanted to write to this node? Let's say, for example, we want to write a new message. And in here, you can actually come in here and specify certain values. So, hello world. Oh my goodness. We'll say the sender is John Turner. And sent time is totally made up timestamp of 1, 2, 3, 4, 5, 6, 7, 8. Whatever that is. We want to write that to message, but obviously we don't want to write it just to the main message node, so we'll make up some kind of key here. And we'll attempt to write here. But that write is denied because we still have a top level write of denied of false. So to get around that, at this top level, we then will write out our nodes. So we have message, and below that, we have user. So now it's time to get some audience participation. What should we have as our authentication and authorization values inside of the message node? What are some security rules that we should have in here? Yep, read. And there's something that's going to be in there. Write. What should we have in here? Auth not equal to null for read or write.
Well, I guess I'll do that for sure.
Okay, so write for sure. We want auth is not equal to null. Okay? And what about read?
Do we need it? Because one cascade down.
It will cascade down. That's very true.
So is it necessary unless we want to change it?
So and that's another great question. So do we want to change it? Let's go ahead and leave it not in there for right now. So if auth is not equal to null for message, let's go ahead and see if we can run this again, this simulation. We'll run this. Looks like it was denied here, but overridden here. So that read was allowed. Again, you guys see that cascade. It does not matter what happens up top. What matters is what happens nested in. So that worked with auth not equal to null. Now, I would say that's really good. Can we take that even further? Can we take that authentication even further? And the answer is yes, we can. And to do that, we're going to actually access some of our current data from within our Firebase authentication. So there is something on the auth that you can grab called .uid. So from within our Firebase rules, we can actually access .uid. Now, what would you guys, just for your collective hive mind, what could we do with the UID attribute from whoever is attempting to write data to further lock down our Firebase?
We could make groups and make like validate it based on groups to see if they're in a specific group. So
Yeah. Yeah, so what you're kind of getting at right there with your idea is that we can query our current database to see if they have certain permission levels or groups, or even to see if that person's UID is actually in our database. Say, for example, that because those two databases are managed separately, say, for example, we remove a user from our system, but we forget to remove them from the authenticated, like the authentication database, or the authorization database, but they're out of our normal Firebase, they could still technically write messages to our system. And so as a first step to what you were talking about, let's go ahead and check to see if this UID is actually even in our user node. And the way that you do that in this write value here is root. Root is a keyword, a reserved word in Firebase security rules that gives you access to your root value right here. So this puts you right here in your database. You can say root.child user dot, and I'm going to increase the width of this so it's not as hard to see. And you could do another .child on there, or you can just say user slash plus auth.uid dot, and I believe it is exists. Could be wrong on that. So someone interpret what this Firebase rule does.
Just check and see if the UID exists in the database.
That's right. So again, the way that our user node is set up is nested beneath it. We have key value pairs where the key is a UID. So we want to check, does the user actually exist in our current Firebase? And what does this also implicitly checks something else. And what is that? Not explicitly, but implicitly.
They have access to it.
That's right, so they're authenticated in the first place. Because auth.uid has to be something. If they're not authenticated, then they wouldn't be able to access it. So let's simulate this write. What should happen at this point? It won't work. Why does it not work? That's right. So if I pop over here and grab my UID and plug it into this Firebase object down here and run it, it then works. So this is also a great way for testing things. You can grab real data out of your Firebase and actually send that up to check it out. Now, something that we are looking at here is that, and I want to point it out, is that our message node, this write rule, technically refers to this point in our message node. All right? It doesn't refer to inside of a test message, or inside of a message rather. And so the way that you can do that, so what we have now enabled is someone to create a new message. That's all we've enabled, is someone to actually write a new node inside of the message node. And that's something you have to kind of wrap your mind around, is as you're writing these rules, think about where you are in your database. A great way that Firebase has given us to be able to get even further into our nodes are the ability to add variables. So if I do $message ID and then nest in there, this $message ID is basically a wildcard for whatever key Firebase creates. You know, I went over the code last time, talked with you guys about how it is that you can have Firebase generate a random key for you for each of our messages. And so if we go, I really hope we don't lose this, just in case we do, I'll copy that. If we go to our data here, we can see these new messages that you guys created all have these randomly generated keys. And we won't know when we're writing these rules what those keys will look like. And so because of that, we can use this $sign variable for message ID. And that means that any key is what we need. So now that we're actually further into this node, let's expand what we've been doing in Firebase security rules. Do we want to secure anything inside of a specific message more so than this top level node? Why would we want to secure that?
Just so that it stays in order and you can't say, oh, I said this 3 months ago when they really just typed that today and then changed the date 3 months ago.
Okay, so we want that only to be, so we only want that to be written once,
Right.
and at that point it can't be written again. Okay? Anything else?
Well, same thing for the message.
Same thing for the message, right? Okay, so we don't want any property of the message to be able to be edited. Okay? Those are all really, really great things. I personally didn't even think about that. And that's something that I'm going to let you guys go on and figure out how to do on your own, because that's outside the scope of what I'm going to teach you today. But that's very, very clever. What I was looking for, as I was fishing for answers here, was no, we don't want to validate, we don't want to secure this anymore. So instead, what we're going to do is validate. I am on fire today. So to validate, I'm going to give you guys just a quick overview. I'm going to give one attribute, an example of one attribute. Oh, yeah, sorry, I was registering a business over there. So anyway, on your message, the way that you validate data, so we're now taking a step from securing our data to validating our data. What we're going to do here is list out inside of a message each of the properties that are in a message. So inside of a message, what properties do we have? Sender, okay? What else? Sent time, okay? Message. And the way that you validate a property is you nest inside of an object, so sender, then you have an object here, and you say .validate, and then you have some kind of validation rule. Now, on this page that I mentioned before, that is securing your data, in here you can go to, I believe it's validating data right here on the right. Here you can do a number of different things, including making sure that your data is of a certain type, so it's a string. You can make sure that it matches a regex pattern. So if you're storing dates in certain formats or you're storing something in a specific format, you can make sure that it follows a regex pattern. You can make sure that the value is actually above something if you're storing a number, things like that. So let's go ahead and do, for this sender, what is it that we want the sender to be? What type? It should be a string, right? It's a name. So we'll say new data. Is that a parenthesis after that? No. Okay. Dot is string, like that. So if anyone attempts to send up, for whatever reason, be it via the JavaScript console or anything, some kind of a value in here that's either a number or anything else other than a string, it will get a permission denied error. So to test that, let's go over here again in our simulator, and we're going to say sender is actually just a number. We'll run this. Oh, sorry, looks like I've on sender. Oh, I see. Got it. All right. It was denied by this validation. So, I can't stress enough how much this made me feel okay with using Firebase for production data. Because up until I started to understand validation rules in Firebase, I felt really uneasy about how easily things could change and how easily things could be written, overwritten rather. So this is giving some structure to our data. So what are we going to do for sent time? Should be a number. So new data dot is, you'd think it was is int, but according to their API, it is number. So make sure that it's a number. And for message,
They're just data types, right? String and number.
you can get a Boolean value as well. That's right. And for here, new data dot is string. Now, you might think, okay, so we're done validating our message object. Not quite. Say, for example, someone goes in, so we have a send time here, we have a sender of GovAllen. Say, for example, someone, because this is all, something that I need to reiterate is because this is all front-end logic, you have to assume, if you're building an Angular app or a React app or anything like that, you have to assume that the person has access to your Firebase and that you have to have this locked down as best as you can. And so because of that, even though your code might be obfuscated or it might be minified or it might be uglified, whatever it is, you have to assume that someone that has way too much free time on their hands will be able to deconstruct your code, get access to your Firebase, and start to try and write stuff to it. And so, say for example, someone decides to add a new attribute here, and they just put whatever they want. Store a string on here. And we run this. That was allowed, which means that you now have that in your database, which means that that could either break your code or you could end up storing stuff in your database that you don't want. And so, there is a great way to fix that. At the end of whatever attributes you have here, you can then toss in a .other variable. .other is a catch-all for anything that is not listed above. And what you can have is a hard-coded validate of false, which means that if anyone else tries to send any other attribute up into this node, when you run that, you'll get that catch saying, hey, everything in here was looking kosher until you tried to send up some new attribute, in which case I'm going to not allow this write. Make sense? Yeah?
So will that stop the entire write, or will it just stop the write of that extra?
The entire write.
Could you do it where you can stop just the extra?
I don't know of a way to do that. The way that I understand Firebase security rules, and I could be wrong on this, so if anyone does some more research and proves me wrong, I'd love to know. The way that I understand it is that Firebase will evaluate all of your security rules for any write they send up, and if even one is off, the entire write is rejected. I don't know of any way to change that. So, and that could be frustrating. It could also be nice, depending on what is happening.
Or it could be nice and frustrating.
Yes, that's right. Yeah.
So let's say they didn't include that second time.
Yeah.
That would still work, right?
Yeah. So let's check this out. That's a great question. Send time in here. We'll also get rid of new attribute because that was breaking. Suspense is killing me. That was allowed. So let's see what is something that we could do to fix that. These are just like JavaScript if conditions, so you can toss in here as many as you want. You can chain them with ands or with ors or with anything. So you can toss into here and you can check. Let's check that out. Firebase security rules. is required. I know of a way to do this, and so I don't want to go right there, but I'm not sure if there's an easier way to do it. Yeah, see, I don't think there is anything that is required.
So the strange thing to me about that is that the value for that has to be null. Like there is no value. So how could you know? Or it just doesn't fire that rule because it's sent time and there's no sent time after.
That's what it is. Exactly what it is you're saying right there.
What I'm saying here is that what I'm thinking is what you're about to do there can't possibly work because it won't be true.
That's right. And so what you have to do instead is move up the node. So you say dot validate. And what would you do in this dot validate here? I guess that should not be an object. If you want to validate in your one node above, what is something that you could do given some code that we've already written in here? You're really close on the right track. However, root deals with anything that is currently in your data, not new data coming in.
So you've got the variable message
Mm-hmm.
that would need to be created.
That's right. We do have that.
No idea what you might do.
That you're kind of, what was that?
Check all the attributes.
Check all the attributes. That is right where we need to go, is checking all the attributes. The way that you do that is, notice that we've got this new data variable that we've been using down here, right? New data will refer to any new incoming data at the specified node. So sender refers to sender at that point. But if we take a step up and it's just nested beneath message ID, new data refers to the entire message that's coming in. So new data.child sender dot exists and need an and here, and this would then be sent time, although it appears that I've accidentally grabbed two things there. Sender sent time and message. So this is the way that I know how to handle this. There could be a more elegant way to do this, but I'm almost positive that that should then work. Oh, had a little bug there. And we need a comma there. And the write was denied because sent time did not exist on that which you're sending up. So you have to think about it from both ways. That was really good. That was a really good question. We've limited what they could actually send up, but at the same time, we need to make sure that what they do send up has all the required attributes. And this is very similar to when you're setting up a table in a relational database. You say this row or this column is required. This one can be null. This one can't be null. All of those things, so that the database layer provides these constraints, so that your application layer doesn't necessarily have to think about those constraints. Instead, it just has to handle the errors that get returned.
Okay, so what I would really want to do in this application is use a common clock rather than a clock I use computer for that message. So can I use this to actually put a value in for that?
Great question. And the answer to that is yes. There are, I think it's on this page, let's see. Now, it's the current time in milliseconds since Linux Epic. And that is the common clock there. And so what you could do in here, which I am not as familiar with because personally, I personally like to gather certain things based off of users' clocks for time zone information as well. But there are different applications for that based on different use cases. You could use the .now. Okay, so you have it there, which you can reference that, or I think you can add that in there. you can reference it, you can use it somehow. Your new data is equal to it or something like that. But I have seen cases on Stack Overflow where you can use that. And again, that is just listed out under their predefined variables. Any other questions?
And you can hit your database at this point as well, right?
Mm-hmm.
So you could
Let's- Are you talking about what we have currently?
Yeah, so here, didn't we recheck? Yeah, we checked to see if that user exists.
Mm-hmm. That's right. So
It seems like you could put all kinds of logic here that's getting executed on the server side.
that's right. Yes, we can, and including checking different things and making sure that certain people are in certain groups, or checking to make sure that you can perform all sorts of queries into your current data when someone runs a call or attempts a write or attempts a read or anything like that. So let's go ahead and save this real quick. Those weren't published yet. We were just using it in the simulator. So these are now published. Let's go back to our application and let's see if we can actually hit our Firebase. So let's start sending some message. I see we now have Donald J. Trump is in our chat room.
I think that might actually be him based on the message.
Yeah, that's right. Let's see if we've got anything in here. Might need to refresh. Come on, baby. It appears as though it is working. Very nice. So our database is now more secured, and we've got some values in here. So now we've got like 10 minutes left in class. Let's go ahead and do the same exercise here, only I won't lead you guys down any paths for our user node. As of right now, our application doesn't have any way of creating new users, but just as an exercise in creating some Firebase security rules, let's go ahead and figure out what is it that we want for creating new users. And this one can kind of melt your brain a bit. How do we want to specify on the top level users node our .read and our .write? First of all, what do these even point to? This read and write, what is that referring to?
Just all of the users that are in that list.
So all of the users, not a single user, that's all of the users. So who do we want to have access to all of the users? Admins. So at this point, we would say maybe there is some kind of a node in our database called groups, and inside of groups we could have admin, and inside of here we could have a list of users. And just like Tyler had mentioned before, we could start referencing groups in our database and say, okay, to read the entire list of users, you have to be inside, your UID needs to be nested inside of the admin group. Okay, so since we don't have that right now, we'll just say, we'll pretend as if we did, root.child group /admin /auth.uid.exists. Exists. Oh my goodness. Okay, and to create a new user. Now this one's a little tricky. Who do we want to allow to create users in our database? Who?
Anyone, if you're on a sign-up process, you need to have to create new people.
Okay, so yes, that's right. How comfortable do we feel about that? Because that, yet again, you have to be under the paradigm, unless you're building an strictly iOS or Android where your code is compiled and people don't have access to your source code, if you're building this for a front-end application, you have to assume that people have access to this. You have to assume that that's the case.
Well, I think that you just want to be able to give a full particular variable, so that particular variable application phase is available such that you can send all these great users non-stop about the applications, validation.
I'm not 100% sure if I follow you on that.
I'm not sure if I follow
Okay, well there you go.
myself.
One thing we can do, so instead of just saying write true and give anyone access here, one thing we can do at the very least is to say auth is not equal to null. And why is that the case? Let's hear from this back row. I haven't heard from you guys yet.
Well, technically, I'm on the back.
That's true. Let's hear from this middle section back row. Yeah. Why is it that we're already authenticated? It goes back to something that I mentioned before. That's right. And what do these rules apply to specifically in our Firebase?
Real-time data.
The real-time database. Where are our authenticated users stored?
Unreal.
That's right. It's stored in the authenticated user database. So technically, through Firebase's APIs, you can go through and you can create a user with an email and a password. And then at that point, it returns back a Firebase user. I had mentioned that very briefly, and I don't expect you to remember the code for it exactly, but the login card, when I sign in, it's the very same thing if I create. I sign in with a user with an email and password. It returns back the authenticated user from the Firebase users database, which is totally separate from your real-time database. At that point, your cookie on your browser is considering you as authenticated. And then if you were to move forward and create a user in the users node, you are technically authenticated. So remember that things cascade. And rather than just fishing for answers here, I'll go ahead and show you a couple things you can do with this as well. You can say new data .child auth.uid. Let's see here. How's that I want to do this? Not at this layer. Auth is not equal to null.
So if that fails, then we can authenticate through Firebase.
Say that again?
If this validation fails, they still have to Firebase user.
They do. They do, and at that point, we need to have some kind of application logic to make sure that that happens. So for example, if the validation fails, it returns some kind of an error, which means that in our JavaScript or in whatever code you're writing, you should have some sort of catch where you catch an error. And in that catch, you could then make a secondary call to Firebase saying, delete that user that we just created. We don't want a bunch of users in our system that we're not using. And that's just handled in the application layer. Yet again, it's annoying, but it's also kind of nice. So inside of this UID, to be able to write, this now means that we are inside of a user object. To be able to write to this user object, we're going to want to make sure that the variable UID is equal to auth.uid. Now what does this expression mean? Who can interpret this expression for me?
You only update your own account.
That's right. Why?
Because the UID for existing accounts can match the one with the one sending request.
That's right. Yep. So if I try and update someone else's account, it will say, nope, sorry, you can only update your own. Yeah.
It's also stop me from creating a number of users in my authenticated.
Yes. So, for example, if you were to attempt to, like, say you're authenticated and you attempt to then go out and create a bunch of other ones, yes, that should, theoretically. So we're minimizing the damage is essentially what I'm saying. Because of the fact that we want this to be quote-unquote open, that anyone can create a user because we want some sort of sign-in process, at the very least, they can't go in and mess with a bunch of other people's stuff. If they're going to write into it, it has to be based on this pattern. And another way we can do this, just with a little bit of time that we've got left here, which I'm just thinking about it right now. We have no sign-up process in this application, so what I'm doing right now, you guys are essentially just having to accept as true, and there's no way to test this. This is a really great way to teach. So what we could do in here, besides this auth is not equal to null, we could also make sure that new data, which again is referring to a new user's node that they're passing in, new data.child, I believe this should work. Actually, you know what? This needs to be nested just beneath it. New data.child, and then we have name. And we can do the same thing here that we did before, where we're validating that all of the things that in our user exists. Email and UID. And again, we can go through this and say, same thing, that we only want people that to be able to view their own user information. And we can go on and add all the attributes. Same thing that we did for the messages node. Any questions about this? I know this is a little bit of a different concept, but it's similar to putting constraints on your relational database tables. Yeah.
Post this on Slack.
Yes. So these, are you talking about just these rules?
Yeah, it's all.
So what I'm planning on doing here is actually taking these,
I'm putting in the rules now.
yep, placing them right here. And I'll get rid of that.
So you can put the rules in your application not straight into Firebase?
No. So in these, all this does, if you have a rules.json file, it allows you to manage your rule. It allows you to keep track of your rules in version control. And so obviously you wouldn't do this if you are hosting an open source application and your code is available openly on GitHub. But if it's stored on a private repo, it's a great way to do this. Since this is also a teaching application, I'm going to do this as well. Plus, I'm going to totally destroy this database later because my API keys are up here, and I don't want people just searching through GitHub and using my database for random stuff. But here, now I'll host this on here. You guys can have access to this and pull it down and look to see what this is like. Now, this will be on the Class 3 branch. Yeah?
Any good ways to like test these rules like automatically? Like just write some use cases, or do you just manually just I'm gonna test the inserting there? Let's see if I can break it.
So I've found that the answer to the question is yes, you can do some tests if you write some unit tests just to make Firebase calls, and you do that in JavaScript or in iOS or Swift or Java or whatever you're using. But I've also found that when I'm actually creating rules in the process of writing them, that it's a much more iterative manual process. Once you've finalized your rules, then I would write a unit test for it just to make sure that if you're using Jarvis or you're using Jenkins. If you're using Jenkins, you've got Jarvis on the mind. You got Jenkins or Bamboo or any other continuous integration service. That way you can make sure that no one's broken your rules that actually work. Does that answer your question?
Yeah.